Okay, let's start with the review here. A randomly chosen subject arrives for a study of exercises and fitness and begins walking on a treadmill at a brisk pace. Which of the random variables is discrete? So discrete, think of discrete as maybe unconnected or countable. Person's heart rate measured by the number of beats in a minute. I think you can measure that. That probably is it. Let's just make sure. The maximum volume of oxygen consumed. I don't think so. The walking speed in miles per hour, that could be like 1.589. Like, I don't think that's discrete. It's more continuous. Amount of time in minutes that somebody walks on a treadmill before his heart rate. So again, amount of time, that's like, you could measure that in nanoseconds. It's continuous. The time in seconds, again, continuous. So I think it would be A. It's discrete, it's unconnected. You're measuring the number of heartbeats. So how many times it beats, it beats 1, 2, 3, 4, 5, 6, 7, that kind of thing. Discrete. Okay, so the score out of 3 points on a randomly selected pop quiz in a stats class, the table gives the probability distribution. Calculate and interpret the standard deviations. First, let's find the standard deviation. So let me get our calculator out, and we're going to go to this one, and I'll put val and proba, just in case I had a prob in there. You could also just start a new document. 0.01, 0.19. Hopefully those add up to 1. That would make it a valid probability model. So to do one variable stats, I usually add a calculator page, control doc, menu 611. So that was val, and then I called this one proba, probs. So 0.795 is our standard deviation. Our mean is 2.26, so 0.795. So I know it could be that one or that one. Okay, so which one looks better? So B isn't terrible, but which one's better? Many, many tests. Is that part of our definition of mean and standard deviation? Yes. Typically vary from the mean. Is that how we say standard deviation? Yes. I would say it's C. Easy one. Vending machine operator has determined that the number of candy bars sold per week at a certain machine is a random variable with a mean of 125 and a standard deviation of 7. His profit on each bar sold is 25 cents. It costs him $5 per week to maintain the machine and rent the space out. So his profit is 25 cents a bar, so 25 times X or whatever the variable is. But it costs $5, so you're subtracting $5. So you're really doing two things to get your profit. You're multiplying the value times 0.25, and then you're subtracting 5. So let's apply the mean to that. So if we do the mean, well, do both multiplying and subtracting affect the mean? I think they do, right? So you would do 0.25 times 125 minus 5. 26.25, looking at these guys, and does multiplying and subtraction affect standard deviation? Absolutely not, only multiplication. So it would be 7 times 0.25, which is 1.75. So it's got to be E. The music files on Sharon's computer have a mean size of 4 megabytes and a standard deviation of 1.8 megabytes. She wants to create a mix of 10 songs for a friend. Let the random variable T be the total size of the 10 randomly selected songs for her computer. What is the expected value of T? So is this binomial? That's my first question. So let's check the bins, right? So does it pass? Mean size of that. She wants to mix 10 songs, so it does have a set number of trials. So it's definitely not binomial. It looks like we're combining random variables here, right? So we have the mean of each random variable is that, the standard deviation of each one, and we have 10 of them. So to get the sum of all the sum of the means, so to speak, sum of x bar, you would do 4 plus 4 plus 4 10 times, right? So I think that would be 4 times 10 is 40. However, to get the standard deviation, or the sum of the standard deviation, that would be the square root of, because you can't just add standard deviations, 1.8 squared plus 1.8 squared plus da 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 10 times, and you do that. So what is the expected value? Oh, the expected value is 40 megabytes, I believe. Okay, so number 5. So let A equal the test of a single roll of 6-sided die. B is the result of a single die roll of an 8-sided die. And the mean is 3.5 of A, and standard deviation 1.71. So we're combining random variables here. So B minus A. So that would be, so B, which the following is true. These are all standard deviations. So let's talk standard deviations here. So, so you do the square root of, it doesn't really matter the order here because you're adding, because it's always the case with these guys. So one of them is 1.71 and one of them is 2.29 squared. And again, I don't really care the order there, but they did the same order I did. So it's this guy. Because you're combining variables, you can't just add standard deviations. You have to change those variances, add them, even though you're subtracting, and get it that way. The MP3 files on Sharon's computer have a mean size of 4 and a standard deviation of 1.8. She wants to create a mix of 10 songs for a friend. What's the standard deviation? Oh, very similar question to what we had a minute ago, but this is about standard deviation. So you're going to take, you're combining random variables, right? So it's like we said a minute ago. So it's going to be 1.8 squared plus 1.8 squared plus 1.8 squared. So get your calculator out. So square root. Okay, so I think if I do it this way, let's see. So if I do 10 times 1.8 squared, I think that's the same thing as 1.8 squared plus 1.8 squared plus 1.8 squared. So 5.691, so there it is. Let's see. A bowler believes the probability she bowls a strike is 80%. Wow, it's pretty good. Suppose she bowls 10 times. What's the probability the bowler gets more than 8 strikes? This is definitely binomial, right? Let's just double check bins. So binomials, getting a strike or not. Independent, each bowl is independent from the previous one. There's a set number of trials, n equals 10. And the same probability of success is always 0.8 is your p. So I might get out your calculator. This is going to be binomial PDF, so menu 55A. So number of trials is 10. Probability of success is 0.8. Oh, wait, more than 8. I didn't do what x is. So x is going to be 9 or 10, basically. So more than 8. So it is CDF. Sorry about that. Got to read the question carefully. So menu 55B. So set number of trials 10, 0.8, lower bound 9, 10. Should be 0.3758. There we go. Row 1, 8-sided die 10 times. What's the probability that exactly 3 7s in those 10 rolls? So we just have to identify our variables here. So n is 10. X is the number of 7s, which is 3. And then P is probably a success. I think it'd be 1 out of 8. So let's see. So we go NPR, but that's our X. So it'd be 10 and 3. You're good. thank you. Okay. And I think it's chance of, so chance of success to the 10 minus, actually this is just to the x, and then failure, which is 7/8, and that one was to the 10 minus 3, so it looks like this guy. Sorry, I got a little sloppy there. Okay, 9, suppose that 40% of cars in a certain town are white. Person stands at the intersection waiting for a white car. Let x equal the number of cars it must drive by until a white one drives by. So this sounds like geometric, right? Until the first white one drives by. And so they even nicely told us less than 5. Person stands at the intersection until a white one drives by. So we want to keep doing this. So because of this, right, we want, okay, so we want geometric CDF. It's kind of a weird question here. So we're going to go geometric CDF. So menu 5, scroll up to geometric CDF. Chance of success is 0.4. Lower bound is 1. That's the lowest you can go. And then 4. So 0.8704. Number of successes in a binomial setting. Here's the histogram. So which one would that be? So in a binomial setting, I don't know. Let's just see what happens if we type some of these in. So let's try one of these. So if we do menu 5A, so if I go number of trials is 8, I guess. Probability of success is, let's put in the first one, 0.8. And just leave that one blank. It gives me all of them. So you can see that the last one is 16%, and then 33% before that. So it's definitely not that one, because that one looks like, I don't know, somewhere around there, and that's somewhere around there. So those are definitely not it. Let's try another one. Try 0.9. So that one's 43, and that's 38. Ooh. I like that. 43 and 38 looks about right there. That's where I had gone to. So I know it's 0.9. The graph is skewed to the left. Yeah, that sounds right. So it's got to be B. So let's check the bins here. So binomial seems like the chance is maybe success is having more than 10 items. So success is that, less than 10 items would be failure. They seem independent. I think it said that, but that seems true. Set number of trials. So 20 customers enter the store. So N equals 20. So that's true. Same probability of success. It's P is 0.75. So it does seem like it passes the test. It's probably that all 20 customers. So this is saying all 20. So X equals 20 is basically what it's saying. So that would be binomial PDF. So you go menu 5A. So number of trials would be 20. Probability of success is 0.75. And at 20 is we want to get 20 successes. So 0.03. So you would show your work by writing that command. So binomial PDF. So n equals 20, and then p equals 0.75, and then x equals 20. And the answer is 0.003. One set, not a very good chance, 0.3% chance. Okay, what assumption must be used for the probability to happen? I think independence is that assumption, right? We're assuming that each customer is independent of the one before them, which is usually true, I would say. I guess it's possible it's not. But typically, I have no connection with the person. What they buy doesn't affect me. Maybe relatives, you could, but we're assuming it's independent. What is probably at least one customer purchased 10 items or fewer? So at least one. So X is 1, 2, 3, all the way to 20, right? So from 1 to 20. So that looks like or binomial CDF. So menu 55B, I think. Whoops, 5B. So again, N is 20, probably excess 0.75, and we want from 1 to 20 to be mostly everybody. Let's see if it gives me a little bit more. 0.999999. So again, you write your answer there. I'm not going to write it this time. Most of the time, that's going to happen, right? Because, yeah. So for apartments in a large apartment complex, X equals the number of people living. What's the problem? Sorry. For apartments in a large apartment complex, X equals the number of people living in randomly selected apartment. The probability distribution is shown below. So there it is. Okay, so this is a different question. Sorry. Okay, there's the probability distribution. Make a histogram of this probability distribution. So you're going to draw your histogram. Your numbers there will be on the bottom 0, 1, 2, 3, 4, 5. What does that represent? The number of people. So you want to label that number of people. On the side, looks like you need to go up to at least 0.3, so 0.1, 0.2, 0.3, maybe 0.4. You just draw your graph. So about 0.12, about 0.20. 2 is 0.31. 3 is 0.14. 4 is 0.16. And 0.07. Something like that. Describe in words. So looks maybe skewed to the right with a single peak at 2. Oh, I thought they're describing the shape. Describe the probability that X is greater than or equal to 2 in words. So remember this. Apartments in a large X is the number of people living in the selected apartment. So the probability that there are 2 or more people living in the apartments in this New York area. And find its value. So I want to find out the probability that so you're going to add up 2 or more would be add these guys up, or add those up and subtract it from 1. So those add up to 0.32, so it would be 0.68. Event, express the event at least one person in terms of X. So probability that X is greater than or equal to 1 is equal to, and then you just do all these added together, or just 1 minus that. So 1 minus 0.12 is 0.88. Picard Partners is planning a major investment. is uncertain. For the research, provide the following distribution. Find and interpret the mean of X. So you want to type this guy in your calculator. I'm going to hit Control Doc. How about just Doc, Insert, Problem. So now when I go to Listen Spreadsheet page, everything's fresh. It's page 2.1. That's good. So I want profit and probability. I don't like calling it probabilities so that I don't have to change it by putting a new problem in there. Whoops. So 1, 2, 4, 10, 0.2, 0.5, 0.2, 0.1. It does add up to 1. That's good. Add a calculator page. Do one variable stats. Oops, you got to choose your prob for a frequency. Should give you the expected value is 3. So the mean is 3. If we took, let's see what the context is. The amount of profit. In millions of dollars. Okay, so those are in millions. So that's $3 million. So, so in every time they have this major investments, if they do this many times, the average amount of profit is $3 million. Okay. Find and interpret the standard deviation. So let's look at that here. So standard deviation is 2.52. So 2.52. So if they do many major investments, the typical variation for the mean is about 2.5 million. That's quite a big difference. Picard owes its source of capital fee of $200,000 plus 10% profit of X. So the firm actually retains that much. So they give you the equation. What's the mean of standard deviation? So what do I do with the mean? So the mean, I'm just going to plug it in. So the y of the mean of X bar would be 0.9 times 3 minus 0.2, whatever that is. And then the standard deviation of the sum of this would be, so that subtracting doesn't have an effect, so it'd just be 0.9 times 2.52. You just do those in your calculators and you get the answers there. Did I do that right for 13B? Let's see. Oh, they did it by hand. I see that. But did we get 2.53? I think we did. Yeah, 2.52. Yeah, 2.53. Yeah. So some of these I was doing in the calculator and they were doing them by hand, but you can see the results there.